Hi everybody, I'm the greatest living inventor, and today we are doing my invention, a blast wave lens. I will write it down. Blast wave lens. Okay, so blast wave, it's like the front of the explosion. You know, the air or the water is the flow is pushed suddenly, and it propagates. It's like a wave, but it's much more sudden and strong. And lens is like a lens of optics, but we use it like in fluids. Okay, so it's not usual that we do this, but that's why it's an invention. Okay, my invention. Okay, so stop mega tsunami. With mega tsunami is a much bigger tsunami. It's caused when you have okay, now I'm explaining what is mega tsunami. Mega tsunami it's when you have, it's not like an ordinary tsunami, it's bigger, and it's caused when normal tsunami is because of an earthquake under the sea or something, and mega tsunami is when you have like a mountain, and you have the ocean, and there is a piece of the mountain, okay, that falls into the ocean. Okay, it like collapses into the ocean, and when this piece falls into the ocean, it pushes a lot of water, and then you have this wave that travels really fast. So this is mega tsunami. And sorry, I will close the door. And okay, so stop mega tsunami with an artificial tsunami in the opposite direction. Okay, we make a tsunami of our own. This is natural, but we make one of our own. I will explain how. That pushes in the opposite direction. It's not exactly pushes, it's interference, destructive interference. It's like that, but we'll talk about it. Destructive interference. Okay. Interference is basically if you have some string or something, and you pluck it, okay, or you make a wave, then there is a wave, and the wave is going like this way. Okay, and if it meets another wave, okay, if here there is another wave, then going this way, then when they meet, they will make each other bigger. Okay, so instead of two waves like that, you will have one bigger because it's they unite. Okay, so this is constructive interference. So this situation of, and this also happens in fluid. Okay, I'm just showing in string. So if you have one the movement is the string itself, okay? It's not like above the string. It's the string that is moving. So it's a disturbance on the string. So let's say we have one disturbance here and one disturbance here. And if they meet, okay, and they are now I drew them in the same phase, okay? So they make up twice as big disturbance. Okay, the amplitude, the distance from here to here, is this plus this. Okay, the height of this plus the height of this. Sorry. And so this is constructive. It's relevant to what we are going to do. And if we have these disturbances, these waves, okay, every wave is a disturbance because it pushes the medium that it is going through. Like the drops of water here push the drops of water further away. So if it's water. So if we have destructive interference, is like that. You have, it's another situation, the opposite situation. We have two waves, but they are not in the same phase. It's called phase. Here they are opposite phase. Okay? So when they meet, they create nothing. Okay, this goes here and this goes here. And when they meet, they cancel each other out. Okay, so this is a destructive interference. Okay, this is a time 1 and this is time 2, and this is time 1 and this is time 2. Okay, or even more accurately I would do 0 and 1. Okay, this is time 0 and this is time 1. But anyway, this is the beginning and this is the end. This is the beginning and this is the end. Okay, so this is constructive interference when they make each other stronger, and destructive interference is when they cancel each other out. Okay? So, okay. So we talked about interference. So I'm reading from the beginning. Blast wavelengths is my invention to stop a mega tsunami with an artificial tsunami in the opposite direction. Okay? We are making essentially what we want to do in the end. It's more complicated, but eventually we do a tsunami like this, okay, that cancel each other. This goes to here, and they cancel each other out, and there is a flat sea. Okay, you can do this in your bath when you're in the water or in a swimming pool. You put your hands towards one another, and if the waves are in phase, then they do a bigger wave. This is a constructive interference, and if they are in the right timing to do a destructive interference, they cancel each other out. Okay, so this is done by positioning explosive charges in an arc and focusing, I will explain everything, and focusing the coordinated blast waves like a lens, constructive interference. The charges detonate inside the water of the ocean or above the water for pyroclastic flow. Okay, pyroclastic flow is another disaster. It's not a mega tsunami, although they can happen if there is a volcano. They can happen like simultaneously, but the pyroclastic flow is something else. Okay, it's let's say this is a volcano. Okay, so the volcano is spitting out lava. Okay, like and the lava, or let's say more exactly the hot gases that are with the dust and like very hot dust and small particles make a cloud, and this cloud, okay, can come. Let's draw an ocean here too. I don't want to ruin that ocean. Okay, and that cloud can go down and push itself forward and forward. If there is more cloud, then it pushes the next one, and the cloud is moving very fast above the water, on the water. Okay, so this is more or less pyroclastic flow. It happened in Krakatoa, okay, Krakatoa. In Indonesia, between Sumatra and Java, and it killed, I don't remember the details, but a lot of people, and it's like a long time ago, but it can happen any time. Okay, so there are places that we know that specific places we know exactly that a mega tsunami is might happen towards a place that we know. Okay, it's like a gun. We know where it's pointing. We just don't know where it's going to go bang, but we know exactly where it's heading in advance. This is critical for the invention. And also with the pyroclastic flow, we have a very good idea where to wait for it. Okay, so also with this, we can make the lens, if you put it above the water, works against pyroclastic flow. If you put it under the water, it works against mega tsunami. Okay, so so now we begin. So I'll take off my jacket. How much time did I waste? Okay, 14 minutes. So I will show you the drawings that I did in my book. So it's like it will save me some time. Okay, I printed it out. Okay, so we know exactly where the mega tsunami is coming from and where it is going to hit. Okay, Wikipedia. I will put all the links in the video description as always. Wikipedia, mega tsunami, one word, mega tsunami, hashtag potential future mega tsunamis. So we have one, Harrison, I will write them down. I will write them down there. Okay, I'll erase everything. You can always go back in the video. And I'll drink something. Okay, so potential future mega tsunamis. It's just to show you that it's important. Potential future mega tsunamis. Okay, so I'll give you 4. 1, Harrison Lake. This is in Canada, near Vancouver. British Columbia, Mount Breckenridge. 2, British Columbia, Harrison Hot Springs. Okay, there is like a lake and it's going from the north to the south and it's supposed to be a mega tsunami. Okay, so this is like Canada. Two, another one. Atlantic Ocean. So this is the only one that I give you that is inside the lake. The other ones are in the ocean. Atlantic Ocean, in the sea. Canary Islands, 2, New York, Miami. To New York, and Miami. Okay, so you understand the danger. There are many people in New York and Miami and all the eastern coast, but especially in the big cities, many people. You cannot evacuate everybody in time. 3, Pacific Ocean. I want to make it clear that the tsunami and also the pyroclastic flow, but especially the mega tsunami, travels very, very fast. Okay, it's like in a few hours it gets there. You cannot go by car because there will be traffic jams and so on. Okay, 3, Pacific Ocean. You cannot escape by car. I mean, if you live in New York, you cannot just get into your car and drive to the inland because many people will want to do the same. 3, Pacific Ocean. Okay, we know it will happen, we just don't know when. Okay, Pacific Ocean, Hawaii to Los Angeles. And of course the western coast and Cape Verde Islands. Okay, this is Canary Islands are there is a Africa, okay, in the western part of Africa, outside of the Mediterranean. So there are the Canary Islands in front of, not far from Africa, and sorry, and the Cape Verde Islands are a little below them. Okay, also opposite of Africa, not far from Africa. Okay, so all this, you see that there are many people in danger. I didn't understand exactly where this is going to hit, but I guess if it's going to the Atlantic, then to South America, like maybe Rio de Janeiro, places like that. Okay, so Fearing the Future, Mega Tsunami, BBC, by BBC Studios. I'll give you the link of YouTube. There is a YouTube link that I will put in the description, and there is a documentary, Fearing the Future, Mega Tsunami. It says it all. Okay. So, with Pyroclastic Flow, remember we said the smoke, the very hot smoke that can travel on the water very fast. With Pyroclastic Flow, it's the same. We know certain places are in the crosshairs, positioned near a volcano that is like a ticking time bomb. For example, this is what happened in 1883 in the eruption of Krakatoa. Okay, remember we said Krakatoa. It was in 1883. So it's like 50 and 150 years ago. Okay. Yeah. Okay, so the pyroclastic flow in Krakatoa traveled on the Indian Ocean water and hit southern Sumatra, Indonesia. Okay, pyroclastic flows, the secret of their deadly speed by nature. There is it's by the scientific journal Nature. It's a YouTube video. I will put it in the description. Pyroclastic flows, the secret of their deadly speed by nature. Okay, so now we are getting to my invention. Okay, so solution. My solution, let's see how much time. Okay, 23.5 minutes. My solution is based on wave interference. Okay, so I'm erasing this. Wave interference. This is what I explained here with the two waves that make each other stronger, or the two waves that make each other flat. Okay, this is a constructive interference and destructive interference. Okay, so you can see in Wikipedia, wave interference. During the first stage, we use constructive interference, waves in phase, okay, waves that make each other stronger. During the second stage, we use destructive interference, waves 180 degrees out of phase, okay, in opposite directions. It's not like opposite directions, they always come together, but it's like we painted one goes upward and the another goes downward. It's like that, okay? Or they are out of phase. In all the following illustrations that I will show you, we are looking at the Atlantic Ocean from above, a bird's eye view. Okay, so like we have, this is the world, and we have South America, we have North America, okay, and South America, and it's like all the lakes here, not lakes, like the sea, and here is let's say New York, and here is England, and all the Europe and the Mediterranean and Africa and Arabia and so on, and here is the Canaries, okay, Canaries Islands. So we have New York on the left in the hour 9 of the clock, and in our imaginary watch I took the pictures from Omega. Okay, the Omega is a watch that I wanted to have, but I didn't have money, so I still don't have money for that watch, but it's that's what I'm using in my pictures, so thank you to Omega. Okay, so I made like a watch, okay, and there is here is the hour 12, and here is 1 and 2 and 3. Okay, so the Canaries are at 3. And in 6 we have nothing, but let's write it anyway. And 7 and 8 and 9. New York is at 9. Okay, 10 and 11. And I have it drawn better in the book, so I will show you the pictures from the book. Okay, so in all the following illustrations that I will show you, we are looking at the Atlantic Ocean. This is the Atlantic Ocean. And it's like we are looking from space or from the sky in a bird's eye view. So we have New York on the left in the hour 9 o'clock of our imaginary Omega watch, and we have the Canary Islands on the right in the hour 3 on our imaginary Omega watch. Okay, it's like, imagine this is a little tilted. Okay, it's like, imagine that they are in the same level. So it's easy to explain with the watch. The original tsunami wave starts from the right and goes to the left. Okay, so the original tsunami is when the Canaries collapse, part of the mountain collapses into the sea. There is a tsunami here, and this tsunami moves to here. So after some time it's here, after another it's here, and we need to stop it. Okay. Okay. So step 1. We place bombs, possibly even small atomic bombs, in the ocean ahead of time, long time before the tsunami, mega tsunami. Each time I'm saying tsunami, it's actually mega tsunami, because a regular tsunami is not so big and we cannot predict where it will be. In a safe distance from the coast of New York. So we make bombs here, but not like very close to New York, a little further. Okay, so we are putting bombs here and here and here and here. And here and here. Okay, and in 12 and 6 we don't, I made a mistake. In 12 and 6 we don't need them. We don't need them because they will cancel each other, so it's like redundant. They don't contribute anything. But if we have this, for example, this bomb, okay, and it explodes, then it pushes the water. So the water goes towards the center. If this is the center, the water goes to here, and they have this component, and they have this component, okay, upwards and to the right. And in 11 o'clock, if this explodes, it also goes downwards and to the right. So the up and down cancel each other out, so it's like non-existent. But the right component of the water is existing. It's like it's contributing to each other. Okay, so it's like there are two components here to the right. Okay, and in the same way here, it's like we have the 8 o'clock and the 10 o'clock. Okay, if this bomb explodes, it makes an arrow to here, so it has a component. We can split this component in the diagonal to straight to the right and also straight up. Okay, this is like, if you know vectors, it will make more sense. And this is like this. If this explodes, the 10 o'clock, then it goes to the center, and we can see it as one to here and one to here. And these two cancel each other. Okay, these two are no longer existent. But these two the components that are going to the right don't have anything to cancel them, so they are they exist. I will draw them where they should be. Okay, so the water gets pushed here. And sorry. Okay, and the 9 o'clock also pushes water. So in general, we have all these bombs make up the lens. This is the lens that I'm talking about, this action of concentrating all the energy towards in this side, all the energy is concentrated, and to these sides, it's like not focused. Here it's focused. Everybody is going in the same direction, like a lens. Okay, this is a lens. And all these together are forming a lens of fluid. And towards this part, backwards, towards New York and towards whatever is here, Canada, it's not focused. It's like spreading. Okay, it's like dissolving. Okay, so step 1. We place bombs, possibly even small atomic bombs, in the ocean ahead of time, long time before the tsunami, mega tsunami, in a safe distance from the coast of New York. These bombs are positioned in a semicircle like a focusing lens. Okay, 35 minutes. Okay, we need to hurry, but then again, most of the pages here are pictures. Okay, so I will show you the picture. I will try not to shake, because my hands always shake, but okay, you can pause if you want. So you see on the right New York, and on the left you have the Canaries and the wave, and the bombs are in 7 o'clock and 8 o'clock and 9 o'clock and 10 o'clock and 11 o'clock. Okay? So, now step 2. The bombs are detonated by remote control all in the same time so that they each create a blast wave. Okay, so each of them is making like a blast wave, and we painted it like an arrow. Okay, also this is making a blast wave, but we painted it like an arrow. Okay, so we talked about it. The bombs are detonated by remote control all in the same time so that they each create a blast wave. Okay, so this is the next picture. Okay, I'm sorry for not holding it steady, but I'm doing my best. Okay, you can pause when it focuses. Okay, so the bombs went off. Step 3. Each bomb's blast wave propagates in all directions. But when this blast wave from the bomb meets the blast wave from another bomb, there is a constructive interference happening, and together all the blasts create one unified artificial anti-tsunami wave that goes from left to right. Okay, I showed you that these components cancel, and the components that are to the right don't cancel. On the contrary, they reinforce each other. So this is a constructive interference. So they make a big, if we put the bombs in the correct places and calculate it beforehand and the timing, then we can make a constructive interference to the right. So we have a natural tsunami coming towards here, and we have artificial tsunami coming from here. Okay, so this is an artificial tsunami, and we make it so we calculate beforehand that its phase is exactly opposite to this one. So it will be like this. An identical wave, but with the opposite. This is the anti mega tsunami. Artificial anti-mega tsunami wave. Okay. So this is this. And it's moving that way. And the tsunami, the real tsunami, is moving this way. And they will cancel each other in the middle, if we calculated it right. If we made this right, in the right direction, in the right phase, it will cancel this one. Okay. So, and together all the blasts create one unified artificial anti-tsunami wave that goes from the left to the right. In the opposite direction, which means towards New York, the waves disperse, the waves that are this way from the bombs in the opposite direction, which means towards New York, the waves disperse because the lens arrangement makes the point of convergence or focal point towards the right. Okay, the lens is like this. Okay, and outside it just disperses and makes it's weak, and here it's getting stronger. Okay, so the focal point is towards the right. At the same time, towards the left, the waves are deconcentrated and diluted. Notice also that there is no sense in placing bombs in 12 o'clock and 6 o'clock because they don't contribute to the desired left to right movement of the artificial wave, plus they will just cancel each other out. Okay, so this is step 4. I'm showing you the picture. I hope it focuses. Okay, so anyway, we have two blast waves, and I show you how they meet each other in the middle, along the 9 to 3 line, along this line from 9 to 3. Okay, so this is what I'm trying to show here. Okay, so step 4. Now here is the tricky part. We must make this artificial anti-tsunami wave out of phase from the original tsunami wave. Okay, out of phase. Out of phase. Okay, this is together, out of phase. This should be out of phase of this. If we get it right, they cancel each other and New York is saved. If we get it wrong, they amplify each other and we get a tsunami that's twice as big as the original, and it will destroy New York. Okay, so like with many things, you need to calculate correctly. But if you do nothing, then this will anyway will destroy New York. Okay, so it's not like you have a great risk. You should get it right to stop this, but it's like the other danger is not like twice as dangerous, because this will alone, if you don't do anything, it will kill everybody in New York. Okay. I don't know how to create an out-of-phase wave, but I guess it requires two artificial waves. The first artificial wave, like we just described, and the second artificial wave a short distance from the first along the same line of propagation. We don't have to create them simultaneously. We can set up two sets of semicircle bombs in large distance along the same line in the beginning, and in the beginning we detonate the first set of bombs, and when first artificial wave passes by the second set of bombs, then we detonate the second set of bombs in the correct timing. So we have one here and another one like in some shift to the right. Okay, like here. And after this got to the desired location, we make another, like imagine if we have a wave here, and then we have another wave here, and these two together, if they are done correctly, are making this this big anti-wave that we want. Okay, it will be something like this. I'm not a physicist, but it will be very much like this. Okay. So I don't know how to create an out-of-phase wave, but I guess it requires two artificial waves. The first artificial wave, like we just described, and the second artificial wave, a short distance from the first. Okay, this is the second, this is the first, this is the second, and they both go to the right. And the second artificial wave, a short distance from the first, along the same line of propagation. We don't have to create them simultaneously. We can set up two sets of semicircle bombs in large distance along the same line. In the beginning, we detonate the first bombs, and when the first artificial wave passes by the second set of bombs, we detonate the second set of bombs in the correct timing. Okay, another possible way, 46 and something minutes, another possible way is to push water downwards, like in a big blast near the surface of the water, and of course a safe distance from the city. I'm sure experts in wave mechanics can calculate these things. Okay, so now I'm showing you the next step, the drawing. Okay, this is when the waves meet. Okay, if I put my hand, maybe it will be easier to focus. Okay, so this is one wave and an opposite wave, with the opposite not in the direction, also in the direction, but opposite in the phase. You see it's upside down, so this symbolizes the out of phase. Okay, step 5. If indeed experts can calculate these things, and we make one wave like this and one wave, if we make such a wave that's moving towards the other one, then when they meet, they will cancel. If indeed experts can calculate these things, then we can even use a recursive solution. Okay, so this is like the next step. If we call this whole system I described above in some name, let's say omega. Okay, so let's call this whole thing omega. So, sorry. So this whole thing, this whole invention is omega. Then we can make an omega of omegas. Okay, imagine small omegas positioned in a semicircle. Okay, so I will show you this in the picture, it's much clearer. I will show it to you now. Okay, so remember this picture, you can freeze it on the page, on the screen. Okay, I will put my big finger so it focuses. Okay, so you see, it's like we have small omegas all around. Instead of bombs, we have small omegas, small copies of this. It's like a fractal. We have small copies. Okay, can you see it? It's like it's focused. Okay, now it was focused for a moment. Okay, so you can freeze it now, and now I will explain. Okay, so the small omegas make one big omega. So, sorry, I turned the page in the wrong direction. So step 5, if indeed experts can calculate these things, then we can even use a recursive solution. If we call this whole system I described above in some name, let's say omega, then we can make an omega of omegas. Imagine small omegas positioned in a semicircle so that they create a huge omega. This allows us to use many small bumps in all the small omegas instead of a few big bumps in one omega like I described at first. Okay, so we can even make do without atomics, for example. Okay, so I've shown you the picture already, and that's it. That's my invention. So I hope it was clear, and I'll see you in my next invention. So thank you very much. Thank you.